Hello, Algebra 2 students. In this section, we're going to be talking about solving equations with rational exponents and also solving radical equations. All right. So before we kind of talk about that, there's a few things you need to mention when we are solving these. Okay. And one of the things we're going to need to do is check for extraneous solutions. So after solving these equations, we must always check for extraneous solutions, okay? And we'll talk about what that means in just a minute. And then in order to solve these, all right, to get rid of a rational exponent, we're going to take it to the reciprocal. The reciprocal fractional exponent, all right? So we'll talk about what that second one means when we go over an example, but we can talk about that first one right now, okay? So what extraneous solutions are, they're basically possible solutions we find that don't work. All right, so let's look at an example here. And this example isn't in your in the notes. I'm just going to write it out, so you can feel free to just follow along or write it in your notes somewhere else. But if we look at the equation, the square root of x equals -1, okay? And we want to solve for x. What we're going to do is, in order to get rid of that square root, we're going to square both sides. All right? So the square root of x squared is just x, and -1 squared is +1. So if we don't check for extraneous solutions, we might look at this and be like, perfect, 1 is a solution. But you have to be careful, okay? I'm going to substitute 1 back into my original equation. So my original equation was the square root of x equals -1. So if we substitute 1 in for x here, we get the square root of 1 is equal to -1. Okay, the square root of 1 is just 1, all right? So 1 equals -1. That's not true. So x equals 1 is not a solution, okay? And that would be called an extraneous solution. So a solution we find through the process of solving that doesn't actually work. All right, and we'll see an example of that later in the notes as well. Okay, so I'm going to erase this now. And then let's talk about that second part. It says to get rid of a rational exponent, take it to the reciprocal fractional exponent. All right, now this example is in your notes, so let's look at the first one here. We have 3 times x to the 4/3 power equals 243. So the first thing I need to do is divide both sides by 3, because I'm trying to get that x and whatever power it's raised to by itself. Okay, so I have x to the 4/3 power equals 81. Okay, so here's where that reciprocal fractional exponent comes in. All right, so I have x raised to the 4/3 power. In order to get rid of the exponent, I'm going to take this to the 3/4 power. And whatever I have to do to one side, I have to do to the other. Okay, so the reciprocal of 4/3 is 3/4. All right, and we have a power to a power, so we're going to multiply those exponents together. All right, and a fraction multiplied by its reciprocal is equal to 1, so this just becomes x. All right, and that equals plus or minus 27. Okay, so because this denominator here is even, we're going to be taking the 4th root of 81 and then cubing it. So the 4th root of 81 is 3, and then cubing it. Well, it's technically plus or minus, so then we're cubing it, so we have plus or minus 27. So these are our possible solutions, so we need to check for extraneous solutions. So what I'm going to do here is I'm going to substitute 27 and -27 back in to my original equation. So we'll do that in a different color. Okay, so we have 3 times 27 to the 4/3 power. All right, and if we just type that in on our calculator, 3 times 27 raised to the 4/3 power, we're going to see that this indeed does equal 243, and that this that when x is 27, our equation is true. All right, let's check when x is -27. So we have 3 times -27 raised to the 4/3 power equals 243. All right, we type this in on our calculator. Once again, we're going to find that this is true. Okay, so 243 equals 243. So both of these check out. So that means that x equals plus or minus 27. All right, both of those are solutions. So let's look at the second example here. Just basically one more step from the previous one. So the first thing we're going to do is going to add 6 to both sides. All right, I'm left with 2x to the 1/4 power equals 8. Okay, and again, I'm trying to get that x term by itself. Okay, sorry, audio cut out there for a second, but I'm trying to get that x term by itself, so now I'm going to divide by 2, and I get x to the 1/4 power equals 4. Okay, so the reciprocal of 1/4 is just 4, so I'm going to raise both sides to the 4th power. Okay, so x equals 256. All right, that's a possible solution. We have to make sure it works. So I'm going to substitute 256 back into my original equation. Okay, so check. So we have 2 times 256 to the 1/4 power minus 6 equals 2. All right, 256 to the 1/4 power is 4. 2 times 4 is 8. So we have 8 minus 6 equals 2, and that is true. So x equals 256 is a solution. All right, let's move on to the next example. Here we have solving an equation with a radical. All right, so what I'm going to do for this problem is I'm going to add the 4/3 of x to both sides, okay, because that makes it so we don't have to deal with that negative later. So I'm going to add the 4/3 of x to both sides of my equation here. I'm left with 5 equals the 4th root of x. So since I'm taking the 4/3 of x here, understand that the 4/3 of x is the same as raising it to the 1/4 power. All right, so we need to raise both sides here to the 4th power. Or simply that if the index or the number outside of the radical is 4, in order to get rid of the radical, I need to raise it to that power. So I need to raise this whole thing to the 4th power since I'm taking the 4th root. So we do that. 5 to the 4th is 625, and then that equals x. So x equals 625 is a possible solution. We need to check to see if this works. So I'm going to substitute 625 back into my original equation. So check here. We have 5 minus the 4th root of 625. Okay, the 4th root of 625 is 5, so we have 5 minus 5 equals 0, and that is true. So x equals 625 is a solution. All right, let's try this next one here. So the first thing I'm going to do is I'm going to add 4 to both sides. And then I have the square root of 2x plus 8 equals 10. Okay, and now that I have whatever is under the radical isolated, kind of like I did in the first, or in example number 3, now I can square both sides. Since this is the square root, I can square both sides. And squaring both sides is going to get rid of that radical. So I can just say that, so the square root of 2x plus 8 squared, again, just gets rid of that radical. So I'm just left with 2x plus 8. Okay, and 10 squared is 100. So I can subtract 8 on both sides. I'm left with 2x equals 92. And then divide by 2. I get x equals 46. All right, so this step right here is really, like, all those steps are really just solving an equation for a variable, something we should be familiar with, okay? So we get a possible solution, x is 46. Now we're just going to check this, okay? So I'm going to scroll down just a tad. All right, so now we have to check our possible solution. So we have the square root of 2 times 46 plus 8 minus 4 equals 6. So 2 times 46 is 92. 92 plus 8 is 100. So we have the square root of 100 minus 4 equals 6. We know the square root of 100 is 10. All right, 10 minus 4 is 6, and 6 equals 6. So x equals 46 is a solution. So I know there is actually 3 more examples, but we're going to skip example 6. So we're going to start with 5 here and then jump to 7. All right. And these, like this example number 5 here, we have 2 separate terms with radicals. Okay. And I know in the past we've wanted to get things to one side or isolate a thing and then square it. But if we have 2 different things with radicals in them, we actually want to get them on opposite sides of the equation. So what I'm going to do is I'm going to add 2 square root of x to both sides. Okay, so I'm left with the square root of 12 minus 2x equals 2 square root x. And now that I have this here, I can square both sides. So squaring both sides is going to help us get rid of all the radicals. So I can take this side and square it, and I can take this side and square it. So squaring the left side just gets rid of that radical, so I have 12 minus 2x. All right, and the right side, I have 2 times the square root of x. So I'm really raising 2 to the second power and the square root of x to the second power. Okay, so 2 squared is 4, and the square root of x squared is just x. All right, and now I'm just solving for x, so I'm going to add 2 to both sides, and if I do that, I get 12, or I'm going to add 2x, I should say. I get 12 equals 6x, then I divide by 6, and I get x equals 2. Okay, so this is a possible solution. I have to check for extraneous solutions now. So let me get a different color. Check here. So I have the square root of 12 minus 2 times x. So since x is 2, this is going to be minus 4. Then minus 2 square root 2. And we want that to be equal to 0. Well, 12 minus 4 is 8, so I have the square root of 8 minus 2 square root 2. And we can simplify the square root of 8 because the square root of 8 is the same as the square root of 4 times the square root of 2. Rewrite the rest of my equation here. And we can simplify one more time. Because 4 is a perfect square, we say that that's equal to 2 root 2 minus 2 root 2. All right, anything minus itself is 0, so this checks out, and x equals 2 is a solution. All right, last example here, and in this one, as you'll see, we'll get 2 answers for x, and we'll see that one of them doesn't actually work. All right, so I already have my term with a radical isolated. Okay, I only have one term with a radical, so that's all I have to worry about. And I'm just going to square both sides right away. All right, so we have x minus 3 times x minus 3. Remember, if we're squaring something like that, we have to FOIL it. And then on the right side, we're just going to have 4x. Okay, so if I FOIL this out, x times x, okay, x minus negative 3, negative 3 times x, negative 3 times negative 3, I'll get x squared minus 6x plus 9 equals 4x. All right, I'm going to move that 4 over. All right, so I'm going to subtract 4x. And I'm going to get x squared minus 10x plus 9 equals 0. All right, so this is a quadratic equation. There's a few different ways we can solve. We can solve by factoring. We can solve by completing the square, which we generally don't do now that we have our other tool, which is the quadratic formula. All right, and if you can't find the best way to factor this, or how this factors nicely, then I would just default to use the quadratic formula. But if you do recognize how this can factor, factoring can be a nice and quick method for solving. All right, so basically we're looking for 2 numbers that add together to give us positive 9 and multiply together to give us negative 6. So we know our terms here are going to be x and x, and since we're adding, or since we're multiplying to be a positive number, but adding to be a negative number, all right, we're going to have a negative, and then we're looking for 2 numbers who multiply to get 9, add together to get negative 10. That's going to be negative 9 and negative 1. So that means x equals 9 and x equals 1 are our possible solutions. So we have to check both of these now. So we have two solutions, kind of like we did in the very first example. We have to check both of them. All right, so when x is 9, we have x minus 3, so 9 minus 3 is 6, equals the square root of 4 times 9, which is 36. And 6 is equal to the square root of 36. So x equals 9 is a solution. Okay, so let's check when x is 1. When x is 1, we have 1 minus 3, which is negative 2, and that equals the square root of 4 times 1, which is just 4. So negative 2 equals 2. That is not true, okay? False. So that means x equals 9 is our only solution, and when x is equal to 1, that's not a solution.